The multiplication property of equality tells us that we can multiply both sides of an equation by any non-zero number we want, and we'll always be sure we haven't changed the solution set to that equation. Our first equation that we have to solve here is 5x is equal to 10. I want to solve this for x, so what I want is 1x instead of 5x. So I'm going to multiply both sides by the reciprocal of 5 in order to get just 1x. So if I do that to the left side of the equation, I do the same thing to the right side. That's the multiplication property of equality. It guarantees that I won't change the solution set. 1/5 times 5x is x. 1/5 times 10 is 2. So x is equal to 2 is the solution to that equation, and I found it by multiplying both sides of the equation by the reciprocal of this coefficient, that is the number in front of x. Our next problem, we have negative 7y is equal to negative 28. I don't care about the negative 28. What I want is 1y instead of negative 7y. So I look at for the reciprocal of negative 7, that's negative 1/7 times negative 7y. If I do that to the left side, I do it to the right side also. Now, negative 1/7 times negative 7 times y is positive 1 times y, which is just y. And negative 1/7 times negative 28 is going to be positive 4. So my solution to that equation is positive 4. I found it by using that multiplication property of equality. Next example, x over 3 is equal to 2. X over 3 is the same as 1/3 x. So x divided by 3 is the same as x times 1/3. Now, seeing it this way tells us that to solve this equation, we're going to multiply both sides by 3. That's the reciprocal of 1/3. 3 times 1/3 is 1 times x is x. 2 times 3 is 6. And isn't that true? When x is equal to 6, 6 divided by 3 is 2, and that gives us a solution to this equation. So when I see a problem like this, x over 3, I'm thinking the coefficient of x, the number in front of x, is 1/3. Its reciprocal is 3, and that's why I multiply both sides by 3. Next example, 3x minus 2 is equal to 7. I want to solve this for x. I notice that I have a negative 2 right here, so I have 2 subtracted from 3x. I'm going to begin with the addition property of equality and add 2 to both sides first to get rid of that 2. Because I want to isolate just x on this side of the equation. So let's get rid of the negative 2 first by adding 2 to both sides. That's the addition property. The left side is 3x. The right side is 9. Now I want just 1x right here, so I multiply both sides by 1/3. I have 1/3 times 9. On the right side, 1/3 times 3x is x, and 1/3 times 9 is 3. So a good problem for you to do, work this enough times so that you can see that first we apply the addition property right here in order to get rid of this negative 2. That leaves me with 3x on the left side. To get rid of that, to change that into just 1x, I multiply both sides by the reciprocal of 3, which is 1/3. So both the addition property and the multiplication property in that problem. Next problem, I have 8x plus 4 is equal to 2x minus 5. Variable term, constant term, variable term, constant term. Let's take all the variable terms and combine them over here on the left side. I'll do that by adding negative 2x to both sides. So I add negative 2x to both sides to begin with. That will give me 0 x's over on this side. So I've moved all the x's over to the left side. 8x plus negative 2x is 6x plus 4 is equal to 0 plus negative 5. Next step, I'll get rid of the 4 here, so I have 6x plus 4 plus negative 4 is equal to negative 5 plus negative 4. This is 6x plus 0, which is 6x. Negative 5 plus negative 4 is negative 9. Now I'll multiply both sides by 1/6, and I'll end up with x is equal to negative 9 over 6, which reduces down to negative 3/2. So my last step will be able to, I'll multiply both sides by 1/6. That will give me negative 3/2 when I reduce that down to lowest terms. So here's a problem where I use the addition property of equality twice, and then I use the multiplication property of equality to solve for x.